Hello, welcome to 12.2. Today we're going to learn about tests about the population proportion. So we're going to be dealing with proportions today rather than means for of what we did for the past 2 days. Now, a one proportion z-test is we can figure out our z statistic. Remember, with proportions we use z's. We take our p hat minus our null p. Now we divide that all by the null p minus 1 minus the null p over n. Square root that. Now, this bottom part is similar to what we did with the means. If p is greater than our null p, then we're just going to look on the right-hand side. If p is less than the null p, we look on the left-hand side, and if it's not equal to, we'll look on both sides. Now, for the normality condition, we have to see that n times the null p and n times 1 minus the null p are at least greater than 10. All right. So many people call this test the large sample test because it is based on the normal approximation due to the sampling distribution of p hat that becomes more accurate as the sample size gets bigger or increases. So just like np is greater than 10, n times 1 minus p is greater than 10. Now, if it is exactly 10, it works, but it's not as good of a normal approximation as if n times p and n times 1 minus p are both very large. So the larger these values are, the closer it will be normal. Closer it will be to a normal graph. But it will still always be a normal approximation. All right, here's an example. According to the National Institute for Occupational Safety and Health, job stress poses a major threat to the health of workers. A national survey of restaurant employees found that 75% said that work stress had a negative impact on their personal life. A random sample of 100 employees from a large restaurant chain finds that 68% of answers yes when asked the same question. Is there statistical evidence that the difference in the national population? All right, so let's do a test on this. So the first thing I'll do is look for my null hypothesis. My null hypothesis is that my population proportion, P, is going to be equal to 75%. My alternative hypothesis will be that it is less than. So P is less than 0.75. All right, I made a little mistake here. I reread the question, and I noticed that this says is different from the national average. So this shouldn't be less than. It should be equal to, because they're just looking for different. So now we want to define P. P is the proportion of people at this chain restaurant that feel that work stress had a negative impact on their life. All right. So we got our hypotheses taken care of. Let's look at our conditions. First, does the data come from an SRS? It says random sample. So data comes from a random sample. Now we want to check normality, and since we always go off the null piece, so 100 times 75, so 100 times 0.75, is that greater than 10? Well, 75 is greater than 10, so that works. 100 times 0.25, which is 1 minus 0.75, well, that equals 25. That's greater than 10. So we can say data is approximately normal. Because 75 is greater than 10, and 25 is greater than 10. So, independence, we're sampling without replacement, so we have to see that n is greater than or equal to 10 times little n. So we want to see that there's more than 1,000. So we'd say maybe observations instead of data. Observations are independent if there are more than 1,000 workers at this restaurant. Chain. Hopefully there aren't, so we can assume that everything's independent. So now we'll look at calculations. Alright, so now we're going to look at our z-test. So we're going to take our proportion that we got minus our null mean. Now we divide that all by our null means standard error. So we got 0.68. We're going to subtract 0.75. Divide that by the square root of 0.75 times 0.25 over 100. Now enter this all into your calculator, and then I get negative 1.62. Now from this, you can do a p-value, and remember, since this is two-sided, we want to do 2 times the probability that x, or that my z-score, will be less than negative 1.62. So that is going to be 2 times 0.0526. So that would be 0.1052. Now, they didn't give us an alpha value, but since this is over 0.1, we would probably fail to reject the null. So we fail to reject null hypothesis because p-value is 0.1052. So we do not have evidence that these workers are have different stress levels or different attitudes towards that stress levels. Than the national average. And this is tough for people to quite understand, especially somebody who doesn't understand much about statistics. If you are the owner of this company and you get these back that your 100 employees got a 68%, said 68% that they felt like the stress was impacting their life, they might think, well, this is much better than the national average. However, it's not enough in order to say that it's even any different than the national average. All right, if the sample of restaurant workers is sufficiently large, we would have sufficient power to detect even a small difference. However, if the sample size is small, we won't be able to detect the differences that are really important. So if they wanted to test this again, if they, instead of testing 100 people, if they tested 1,000 and got 68%, that would be significant. But just testing 100 might not give you enough. Um, and in this case, it didn't give us enough evidence to reject that they're any different than the national. All right, here's one more example, and then we're done for the day. Shaquille O'Neal had made 53.3% of his free throws. He decided to work on his free throw technique over the offseason. During the first two games of the next season, Shaq made 26 out of 39 free throws. Do these results provide good evidence that the change significantly improved his free throw shooting? All right, so let's take a look at our null hypothesis. Our null hypothesis is that P is equal to 0.533. Our alternative hypothesis, we want P to be greater than 5.33 because we want him to improve that proportion. Now, we'll have to say what P is. P is the proportion of shots that Shaq makes. All right, for conditions. Now, this isn't from an SRS. And it wouldn't even make sense to take an SRS in this situation. Um, now we want to check normality. So we'd have to see, we'd have, we did 39 times. So we'd have to do that times our null. So 39 times 0.533. Check that that's greater than 10. And then 39 times 0.467. See that that's greater than 10. Well, on the left-hand side, 39 times 0.533, that's 20.787. That's greater than 10. 39 times 0.467, that's 18.213. And that's greater than 10. So we have evidence, so data is approximately normal. Because of this. So we have to assume each shot is independent. Now we don't have to see that the population is 10 times bigger than the sample, because it just doesn't make sense that he can shoot over 390 shots. It just doesn't make sense in this particular situation. All right, calculations. So we want to do a z-test because we're dealing with proportions. We're going to take our p hat, subtract our null p, divided by the square root of our null p times 1 minus our null p over the square root of n. So our p hat, what is that? I don't think we even figured that out yet. 26 out of 39. 26 out of 39 gives us 0.6 repeating. So 0.6 repeating. We're going to subtract from that 0.533. We're going to divide that by the square root. I already did this. So that's 0.1336. So let's do just 0.134. Now this denominator is going to be 0.533 times 0.467 over n, which is 39. So 0.533 times 0.467. Divide that by 39 and square root that answer. This is 0.0799. So 0.134 divided by that previous answer, I get a z-score of 1.677. All right, from that z-score, let's find the p-value. Now, our alternative hypothesis is greater than. So we're going to find the probability that my z-score is greater than 1.677. So I'm going to do a normal CDF from 1.677 to a very large number, which is 0.04677. So that's below 0.05. So we can interpret. Since it doesn't give us a alpha value, we'll assume 0.05. So we reject the null hypothesis because the p-value is 0.04677. So we have evidence that Shaq improved his free throw shooting. All right, there's 2 examples. So hopefully that can help you get through this homework.